Section 6.5b, some more properties with logarithms. This is just some more practice. Getting the hang of these logarithms can take just kind of some little practice looking at the different properties. So this one, use the properties of logarithms to find the exact value of each expression. So here we have two different logs, same bases, two logs, same bases, with the subtraction in between them. That's this property right here, the difference of logs. We can write this as a single logarithm, log base 8, where we do the first over the second, and that's going to be log base 8 of 8. Well, this is saying 8 to the first. 8 to the first is equal to 8. So all said and done, our grand total answer is going to be just 1. This one here, use properties of logarithms to find the exact value again. Well, in here, in this exponent, we have a plus between two logs, same basis. So I can use the property of product, the product property. So we're going to have 5 to the power of log base 5. When there's addition between them, it's going to be multiplication of what's inside. So 6 times 7. Like that. Oops. And then we have 5 to the power of log base 5 of 42. Well, keep in mind logs are inverses of exponents. So here we have 5, an exponent of log base 5. Those are inverses. They're going to undo each other, and we're going to be left with just 42, like that. Here, we want to get some practice writing the expressions as a sum or a difference of the logarithms. So express powers as factors. As a sum or a difference, here we have a quotient. So we're going to use the quotient right here. It's log base 5 of the top part, which is the x, minus log base 5 of the bottom part, which is 25. Here, there's nothing we can do with this part, so it's going to be log base 5 of x minus, this is saying 5 to something is 25. Well, that 5 to the second would be 25, so log base 5 of 25 is just 2. That would be our answer. If you need to, this log base 5 of 25, that's the same thing as log base 5 of 5 squared. Here again, we have kind of inverses of each other, so we'd be left with the 2. This one here, write it as a sum or a difference again. This x is greater than 5. That's to keep the domain working nicely. So here we have a quotient. So we'd have log base 2 of the top minus log base 2 of the bottom. The second part, I don't really see anything I can do with that. But here we have a power, so that's the log of a power. That's this property right down here. We'd have the power can go out front, so we have 2 log base 2 of x minus log base 2 of x minus 5. Write it as a single logarithm, 2 log base 3 of r minus log base 3 of k. Well, here we have a number out front. That number out front can go to be the power. So we're going to have log base 3 of r to the second minus log base 3 of k. Now we have a difference, which can be written as a quotient. So it's going to be log base 3 of r squared over k, like that. And now we have it as a single logarithm. This one, write the expression as a single logarithm. I don't see a base there because it's considered the common logarithm. It's base 10, even though we never write it there. That's what's there. So we have log, a subtraction between them. This is x squared plus 2x minus 3 over x squared minus 4. That's the top. Should have made this a little bigger. That's the top. And then the bottom is what's over here. X squared plus 7x plus 6 over x plus 2. When I see something big like that, I'm guessing we can somehow probably simplify it. So this is going to be a log of the top. When I look at the top here, x squared plus 2x minus 3, I'm starting to wonder maybe if I can factor these tops and bottoms. But first, I'm going to multiply by the reciprocal, x plus 2 over x squared plus 7x plus 6. And again, I'm wondering maybe I can factor some stuff on the top and the bottom so that it will simplify. The top of this one factors into x plus 3, x minus 1 over x plus 2, x minus 2 times x plus 2 over x plus 6 times x plus 1, like that. I was hoping for more simplification, but in the end it looks like the only thing I'm going to be able to simplify is the x plus 2. So this ends up being log of x plus 3 times x minus 1 over x minus 2, x plus 6, and x plus 1. And then we have a single logarithm. Some more log jokes. Like I told you, these jokes have an exponential number, and this slide or this video was just to give you a few more examples, and then the homework is to give you a little more practice because you really want to be proficient at using these properties of logarithms.